What's up, alchemists? In Full Metal Alchemist Brotherhood, Ed and Al delve deep into age-old cookbooks,
Written by Tim Marco.
much like our modern dictionaries, to unravel the mysteries of the Philosopher's Stones, its properties, and associated values. So let's embark on a similar journey with Python dictionaries. Using the knowledge from the dictionaries, alchemists harness the laws of equivalent exchange. Just as in Python, dictionaries allows us to transmute keys into values. So let's show you how. But first, we'll have to create a dictionary. We create a dictionary called Older Brother.
Big brother, little brother.
Inside the dictionary, we create two squiggly brackets and we put our data in between it. In this case, we put our key wrapped around quotes and then has a colon at the end, followed by your value. If you're adding multiple key and values, you always need a comma after your value. And that is how you create a dictionary. These are great for databases. They're mainly key value pairs and they can be used for dictionaries, structured data, keeping track of user IDs, what type of access somebody has, and a bunch of different use cases. But they are great for quick retrieval of data. Let's now discuss the magic methods in dictionaries of keys, values, and items. These are like essential runes in our transmutation circle. We have here our print function with our variable older brother, our keys, values, and item methods. When we run this code, we're going to see it spit out a bunch of different information. We're going to get just the keys, just the values, and a combination of both. Let's go ahead and run this. So right away, you see we get dict keys, name, rank, trait, dict values, ed, Fullmetal Alchemist in short, dict items, name, ed, rank, Fullmetal Alchemist, and trait in short. So this spits everything out all in one shot, and these methods are great if you're unsure of what the keys and values are in a dictionary. You can use these methods to find them out. There's also another way of accessing methods inside of a dictionary. We have this other variable called younger brother.
The younger means little. You're little.
Inside younger brother, we have our keys of name, rank, and trait as well. And we can access the information that we have. This way we're going to access it. It's just called key-based lookup. And this is great if you already know what's in the dictionary. We know what keys already exist. So you run all three of these, we're going to get back the exact values. We'll get al, none, and then soul bound to armor. And that are two ways of accessing your keys and your items inside of the dictionary. And just remember, alchemy always requires precision, and so does modifying a dictionary in Python. We must understand the composition before any transmutation. What if our alchemy needs to be deeper, layered? Yes, dictionaries can be nested. Let's see a multi-layered transmutation. So we'll go ahead and take the variable of Elric brothers, and inside of that, we'll make another dictionary called older brother with its specific keys and values. And then inside of it, we'll make another dictionary called younger brother with its keys and values. And just like before, because we already know what the keys are, we can run this code and get back all our values based on our keys. And here's all our data. This is a great way to save on writing multiple different codes. We can just nest our dictionaries, and it makes it very easy to write our code and just keep everything nice and structured and nested and pretty. We discussed this in a previous short. I went through having a bunch of state alchemists inside of our dictionary where we went through them all and they had their name and their ranks. Well, if you look at number 4 and 5, we do not have those ranks. And if we were to run this without the get method, you would get a key error because it wouldn't know how to access this. And what's nice about the get method is that we can give a key and we can also give a default value. The state alchemist 4 entry has a name but no rank. We want to make sure that if there's an entry with no rank key, we mark it as candidate. We're then saying that the candidate is a default level for anyone who is not a state alchemist yet. We are then saying name, like this person, entry state alchemist number 5, that has a rank but no name. So we're going to use the get method to look up the name. If there's no key found, define it as unknown. So we can go ahead and then use our print function with our F key and the two variables that we set up to print it out. And when we run all this, we get back all our correct data of Edward Elric and all the different ranks for each person. And then if you noticed 4 and 5, Raven Bergdragon, rank as candidate, the name is unknown and the rank is still Brigadier General. This is a great way to set different things if you setting default for your structured data if you have missing keys. But what if we have a nested dictionary and we want to do the same thing? So we can take a nested dictionary, we create it like we did up over here, and we'll create our main dictionary called State Alchemist DB, and inside that we'll make smaller dictionaries of State Alchemist 1 through 5. What we're going to do differently here though, instead of just doing 4 SA and a State Alchemist database, we're going to create some internal variables of one called called for state alchemist ID, which is going to create an ID variable, and then also state alchemist info, which is going to print out all the info we have from each person. Again, we're going to use the get method with a default value, same as we set before. The only thing that changes is that we're changing the for loop to add some extra information to keep things structured inside our nested dictionary. So everything is pretty much similar besides the change of our internal variables in our for loop. And the biggest difference here is that we're getting in the state alchemist DB, grab all the items. And if the items of name or rank are missing, set name to unknown and set rank to candidate. So we'll go ahead and run this information. We get back the ID of state alchemist 1, 2, 3, 4, 5, their name and their ranks. And again, if you've noticed, 4 is a rank candidate, 5 is name known. Dictionaries are practical, and you can think of them alchemical books for Pythonists, containing vast knowledge from data storage to frequency counting. Their applications are immense. They are great to use, quick for retrieval, awesome database management, and just great to learn, and an overall useful arsenal in your alchemy toolbox. But if you're ready for more alchemical adventures in Python, make sure to hit that subscribe button and let's keep it transmuting together. I appreciate you watching this. I'll see you in the next one. Peace out, alchemists.